Okay, it's Algebra 2, Unit 7, quiz number 3, day 15 quiz. We've got 10 questions. Number 1, evaluate the series. When they say evaluate the series, I mean to add them all up. So in the series, you got 1 plus 4 plus 16 and so on. Okay, you'll notice that each term in this series, or if it's, you can think of it as a sequence also. It's going to be a geometric sequence, right? If you see it as if it was a sequence, it would be geometric. So there is a formula for a summation for a geometric sequence, and that's going to be sum of n terms in a sequence, if it's geometric, is going to be a sub 1, that's the first term, times 1 minus r to the n, all over 1 minus r, where r is your ratio, and a sub 1 is the initial term, and n is the number of terms that you want to add together. So let's go ahead, or I should say the number of what's the nth term that you want. All right, so let's try this. We want the sum of the 6 terms. We have 6 terms there. That's going to equal a sub 1, which is 1 times 1 minus r to the n. In this case, r is 4. And it's to the 6th power, all over 1 minus r, which is 1 minus 4. All right, so all we have to do is evaluate this. We can distribute the 1, right? It doesn't do much. All right, so it's 1 minus 4 to the 6th over 1 minus 4 is negative 3. 4 to the 6th is 4,096, so 1 minus 4 to the 6th is 4,095, negative 4,095. And then over negative 3, the two negatives will cancel each other out, and you're left with 1,365 as a total of those 6 terms, without having to sit there and just add them all up. We can just use the formula, and it will get our sum. That's the sum of those 6 terms right there, and that's what you want. So first thing is it geometric or is it arithmetic? If you need to evaluate the series for a geometric one, you would use this formula. The next one's pretty much the same. You got 6, and then a negative 24, and then a positive 96. So you can see that's multiplied by negative 4 each time. All right, so that's your r. Okay, it's multiplied. This should be a times sigma. You're multiplying by negative 4 each time. Okay. Now, so it's a geometric sequence, and it wants you to evaluate to s of 7. Okay, so it's 7 terms that you want, the first 7 terms, and you want to get the sum of all those in this geometric sequence. So we have r, right? R is negative 4. We have our first term, which is 6. We also have how many we're going to be evaluating here. Up to what number are we getting the sum for? So s of 7 is going to be 6, which is the first term, times 1, let's see this a little better here, times 1 minus, and here it's going to be r to the n, so it's a negative 4 to the n, or excuse me, to the 7th. We know what n is, don't we? So it's to the 7th. And I'm going to put my parentheses there just to help me a little bit. And remember, the 6 is going to multiply out at all. So what we can do is to just help us remember to distribute that 6, we can use some brackets around. That makes it a little bit more understandable. And then it's 1 minus negative 4. So remember, you have to substitute. If r is negative, you got to use the negative and substitute the whole number in. So that's negative, by the way. So it's 1 minus negative 4. Okay, so we just evaluate this. So it's 6 times 1. Now it's going to be minus a negative 4 to the 7th. And let's see. 4 to the 7th is 16,384. And it is negative. So when we do this, That's a 4 on there at the end. All right, when we do this, those two negatives are going to actually cancel each other out. And it's 1 minus negative 4 on the bottom, right here. So that's going to give us 1 plus 4, which is 5. Okay, so let's put this all together there. 6 times 1 plus 16,384 over 5 is what we end up with. All right. And 1 plus 16,384 is 16,385, and then times 6 will give you 98,310, and then you divide by 5, and that's going to give you 19,662, and that is your answer for the sum of all of those up to the 7th digit, up to the 7th. I'm sorry, not the 7th digit, up to the 7th term of this series. Okay, number 3. Evaluate the series 1000 plus 500 plus 250. Okay, so automatically you know right away that it's going to be dividing or multiplying by a half, however way you want to think about it. So let's use r as 1/2. And it wants us to evaluate to s of 5. So we want the sum of the 5 terms, and we have our first term, right, which is 1,000, and we have our ratio, which is a half. So we just use our formula again. So this should start getting a little bit familiar to you as you're doing this. So it's 1,000 times 1 minus, and it's the ratio to the power, so it's 1/2 to the 5th all over 1 minus r, so it's 1 minus 1/2. Okay. All right, so let's take a look at that. We have, in parentheses, half to the 5th power. 1/2 to the 5th power is 1/32. If you just take each one to the 5th power, you're going to end up with 1 over 32, because 2 to the 5th is 32. So 1/2 to the 5th is 1 over 32. You only do a little bit of job there. 1 over 32. All right, so you have 1,000 times 1 minus 1/32 all over 1 minus 1/2, which is 1/2. And you just use 0.5. There's 1/2 if you want, or multiply by 2, either way. So 1 minus, and we can just evaluate this in here. 1 minus 1/32 is going to be 31/32. So 31/32 times 1,000, and then times 2, essentially, because we're going to divide by half, so we're just going to multiply by 2. Or, you can think of it as a reciprocal, times 2 over 1, whatever. Okay, so 31/32 times 1,000 times 1,000 is going to be 968.75. And then if you multiply that by 2, that's going to give you 1,937.5. And that is the answer. All right. Next up is number 4. Justine earned $17,000 during first year of her job at the City Hall. After each year, she received a 4% raise, so find her total earnings during the first 5 years on the job. So basically, we want to know what, year 1 plus year 2 plus year 3, so on and so forth. You want the total of what she's going to get for all those 5 years. So you can imagine if she puts all the money she makes into her savings account and doesn't spend anything, in 5 years, how much will she have? And assuming that she doesn't have any, she doesn't earn interest on her money. So let's just imagine she's putting in her every dime she makes into her piggy bank, and after 5 years, she wants to know how much money she's going to have. So we can do this using the sequence, right? What's R? Well, R in this case is going to be 4%, but it's got to be 1.04 because it's got to account for her. She's not going to make less money. Next year she's going to get a raise. So it's got to be 1 plus 0.04. It's going to be 1.04 for R. Your first item in the sequence is going to be 17,000. The first term of the sequence is how much money she starts with. That's her first year's amount. So obviously, since you're multiplying by this ratio here, it's going to be a geometric sequence. And how many years? It's 5 years. So we have to get the sum for 5 years. Well, what's that? Well, it's a sub 1, which is 17,000, times 1 minus 1.04 to the n, all over 1 minus 1.04. Okay, now instead of n, we don't need n, we need a 5. It needs to be a 5 right there. So now we have that, and we're ready to go. Now it's just a matter of crunching the numbers. So when we do this, it's going to have your 17,000 times 1 minus 1.04 to the fifth. So when you distribute, you're going to have 17,000 minus 17,000 times 1.04 to the fifth. 1.04 to the fifth is like 1.2166. It's just, so when we do this, you're going to get something like 17,000 minus, it's just going to be 17,000 times 1.04 to the fifth. Alright, so you're just going to get a calculator, figure that out. What you're going to end up with is something like negative 3,683.0993408. I'm just keeping this because it's would be a calculation, and I want to have an accurate calculation. So 1 minus 1.04 is negative 0.04, and so I just divide it out. The negatives cancel out, and my total is going to be 92,000. Sorry, let me kind of make a little space. Here, $92,000. Sorry, $92,077 approximately is going to be her earnings total for 5 years. That means every year, if you add up everything she makes for 5 years, keeping in mind that she's getting a raise, so she's making a little more every year than she made the year before. Okay, so it's $92,077. And that is it for that one. We have also number 5, evaluate the series 1 plus 2 plus 4 plus 8 to s of 10. Alright, well, again, it's a geometric series, right? Geometric sequence of the terms. Our first sequence is 1, and our ratio is 2, so s of 10 equals 1, that's our first term, times 1 minus 2 is r, we want the 10th term, and then all over 1 minus r, which is 2 in this case. And so we get 1 minus 2 to the 10th. So you can just ignore this 1 times here because that's going to give you identity property anyway. And we can just evaluate 1 minus 2 to the 10th, which is the same as 1,024, 1 minus 1,024, and 1 minus 2 is negative 1. Alright, so 1 minus 1,024 is negative 1023, all over negative 1. Negatives cancel, and this works out really easily, 2023. And that is the evaluation. That's it. That's the sum of those terms in this geometric sequence. Now, number 6, in June, Corey begins to save money for a video game and a TV he wants to buy in December. He starts with $20 each month, so that's our ace of 1. So as you do these, you can start identifying what terms you're going to have. Each month he plans to save 10% more than the previous month. So this is like the person that's working gets a raise every year, right? So a ratio in this case is going to be 1 point because he's going to put in the same amount plus 10% every single month than the previous month. So it's going to be 1.1 is going to be R, 1.10 if you will. And we want to know how much money you will have at the end of December. So how many months are we talking about from June to December? We're talking 7 months. So the sum for 7 months is going to be first term times 1 minus, that's your R, 7 is your power, all over 1 minus R. And when you multiply this all out, you're going to get, 189.74. That's how much money he's going to have if he puts away 10% more every month than he did last month, starting with $20 in June. That's how much he's going to have in December, $189.74. Next part, 7 and 8, we talk about diverging and converging geometric series. That means that basically, if it, let's just start with diverging, okay? If it's divergent, geometric series just depends on your R, right? What's your ratio? So divergent is whenever the absolute value of R is greater than 1, even if it's negative, you're going to be going up to infinity. There's going to be no limit here. All right. Well, if it's convergent, it's the opposite. Convergent means that the absolute value, and the absolute value is very important here, the absolute value is less than 1, greater than 0. Okay, so convergent and divergent. So convergent means that the limit is going to approach a limit. And divergent means it just goes infinity. You cannot get a sum. You cannot evaluate the sum, but you can evaluate this sum because it approaches a limit. So in number 7, R is what? Well, it's 1/5 and then 1/10 and so on and so forth. So you can see that it's multiplying by 1/2. And since it's multiplying by 1/2, the absolute value of 1/2 is greater than 0, less than 1. So it converges. It's convergent. Okay, it converges. And the explanation is that the absolute value of 1/2 is indeed less than 1, greater than 0. And that's the reason behind it. Number 8, same kind of question, different numbers. With this, is it going to be convergent or divergent? Your sequence is times 3, so R is 3. So the question is the absolute value of R greater than 1? If so, then it's convergent, and that is true. So it is greater than 1. The absolute value is greater than 1. So it's divergent. And that's the reason why. And that's your answer. Okay, for number 9, evaluate the infinite geometric sequence round to the nearest hundredth if necessary. In these cases, since we have a convergent series, we can get the sum. You have 8 plus 4 plus 2. So you can see how it's going to be approaching 0 here. it's multiplying by 1/2. So r is 1/2. Ace of 1 is 8. So your sum of the convergent series is going to be ace of 1 over 1 minus r. It's essentially like the sum that you were doing before, just without the 1 minus r to the n part. So what's going to be the sum of this? Well, we just kind of put in our numbers. Ace of 1 is 8, and 1 minus r being 1/2, so it's 8 over 1/2, which is the same as 8 times 2, which is 16. So our infinite geometric sequence sum is 16 on this one. And remember, you can only get the sum if the absolute value of r is greater than 0, less than 1. Okay, 10. 1 plus 0.1 plus 0.01. Okay, what's the pattern mathematically? It's times 1/10, right? So is this divergent convergent? It's convergent. So we can find the sum. So the sum is going to be our first term, which is 1 in this case, right here. Okay, that's ace of 1 over 1 minus r, and so that's 1 minus 0.1. And so we get 1 over 0.9, which is going to be 1.11, and just kind of continues. So that's our answer. Once around in the nearest hundredth. So 1.11 is fine. Let's just leave it at that because once it rounded. 1.11.